Physics Part 172. So we continue with our section summary. I have already provided you few points. So continue with the last point we discussed and then a few more ones. The intensity of a wave is energy passing through unit area per unit time. Intensity is proportional to the square of the amplitude and to the square of the frequency. The speed v, frequency f, and wavelength lambda of a wave are related. V is equal to f into a. Properties of wave motion: reflection, refraction, diffraction, and interference can be observed in a ripple tank. We've got some section questions. A certain sound wave in air has a speed of 340 meters per second. Wavelength is 1.7 meter. For this wave, calculate A, the frequency, B, the period. Number 2, the speed of electromagnetic wave in a vacuum or air is 3.0 into 10 power raised to 8 meter per second. A, the visible spectrum extends from the wavelength of 400 nanometer blue light to 700 nanometer red light. Calculate the range of frequency of visible light. B, a typical frequency for VHF television transmission is 250 megahertz. Calculate the corresponding wavelength. Number 3, two waves travel with the same speed and have the same amplitude, but the first has twice the wavelength of the second. Calculate the ratio of the intensities transmitted by the waves. Number 4, a student stands at a distance of 5 meters from a point source of sound which is radiating uniformly in all directions. The intensity of the sound wave at her ear is 6.3 into 10 power raised to minus 6 Wm square. A, the receiving area of the student's ear canal is 1.5 centimeter square. Calculate how much energy passes into air in 1 minute. B, the student moves to a point 1.8 meter from the source. Calculate the new intensity of the sound. Now we get to the next point, next topic, polarization of waves. Well, at the end of this section, you should be able to show an understanding that the polarization is a phenomenon associated with transverse waves. Thinking about generating waves in a rope while moving your hand holding the stretched rope up and down or from side to side, the transverse vibrations of the rope will be in just one plane. The vertical plane if your hand is moving up and down, or the horizontal plane if it moves from side to side. The vibrations are said to be plane polarized in either a vertical plane or a horizontal plane. However, if the rope passes through a vertical slit, then only if you move your hand up and down you will have wave pass through the slit. This is illustrated in the figure. If the rope passes through a horizontal slit, only waves generated by a side-to-side motion of the hand will be transmitted. If the rope passes through a slit of one orientation followed by one of the other orientation, the wave is totally blocked, whether it was initially in the vertical or horizontal plane. Transverse waves on a rope area plane polarized.